Okay, my dear students, how do you solve this problem in a super simple method? I have dedicated my 2 years for creating short tricks. So hope you'll enjoy this dedication. So now you can see here, force, energy and velocity. In this problem, if you observe, force, energy and velocity are chosen as fundamental quantities of dimensions of acceleration. Okay, so what are we going to do here? Let us see. For example, acceleration means you all know it is force by mass. Is it okay? So force is there in the question, and mass, what I am going to do, I am just writing mass multiplying with v square by 2 whole divided by v square by 2. That's it. So what I am going to do now, it's very simple. I am multiplying v square by 2 divided by v square by 2 so that you will get the same mass here. So but what I am going to get, let us see here now. Acceleration, force will be like that only. Half mv square is nothing but kinetic energy, so I am writing energy like that only. Okay, and what is left here, v square by 2 is left. It will come to the numerator, that is v square by 2 here. Okay, so and you know that 2 does not have any dimension, so remove it. So you can write now a is equal to f v square e power minus 1. Your answer is ready. Hope you have enjoyed this short trick. Thank you very much. Students, how are you going to find out the super simple method to find out the expression for surface tension? Expression for surface tension. Okay. Here, expression of time period in terms of surface tension, radius and density. I'll tell you super simple method instead of rising of powers here. Okay. How is the super simple method? Let me discuss here. You all know time period is equal to square root of L by G. And let us take here now. Force is equal to mass into gravity. Now, mass is equal to volume into density into gravity. Now, volume is nothing but r cube. Let us take volume means length into breadth into height, which is taken as r cube. So, r cube rho into g here. Okay. If you substitute this value here, then you can take here g is equal to f by r cube into rho. That's it. So, you write tension is equal to square root of L. You write like that only. G means f by L whole divided by r cube by rho, means this comes to the numerator, that is r cube into rho. Okay. Okay. Then after that, you know tension, surface tension is nothing but force by length. Okay, so this is surface tension, which is equal to force by length. So you write now square root of r cube into rho divided by surface tension, force by length. It's a reciprocal here, so we can write surface tension, yes, because you can write f by L is, S is equal to f by L means L by f is equal to 1 by S. So you are written like this. So this is going to be your answer. Okay. Now you know time period. You can write this time period as 2 pi root of L by G here. 2 pi is nothing but constant, so you can write K here. That's it. The simple, super simple method to solve this problem. Hope you have understood this one. Enjoyed. Thank you. Okay, my dear students, how to remember the most popular dimensional formula asked hundreds of times in previous year questions, that is coefficient of viscosity. So how can you find out the dimensional formula for coefficient of viscosity, which is shown here? For that, you have to remember one concept actually. Let us take there is some liquid here. Okay, so this is a liquid. For example, if I throw any iron ball inside the liquid, what happens on that iron ball? Okay, there is a type of viscous force acting on that iron ball. So it falls down. So viscous forces are acting on the iron ball upwards, and this viscous forces is directly proportional to radius of the ball. Viscous forces is directly proportional to velocity of the ball also, with which you are going to throw it inside the water. And even viscous forces are directly proportional to coefficient of viscosity of the liquid. Coefficient of viscosity of the liquid. Okay, then what is going to happen if you join all these terms? So I'm going to join all these terms, and finally we're getting here viscous forces are directly proportional to R neta V. So if you remove this proportionality, you will get a constant K, and you'll be writing R neta V. So with this formula, it is easy to remember the dimensional formula for coefficient of viscosity, which is our requirement. So if you want to find out the dimensional formula for coefficient of viscosity, it is very simple that you all know constants does not have any dimensions. So remove this part, then you will write viscous forces divided by R into V, velocity. Okay, so what I'm going to do is, you know mass, force is nothing but mass into acceleration Lt power minus 2. Okay, so this is about the viscous forces. Then after that, radius is nothing but L, and again velocity is nothing but Lt power minus 1. Okay, Lt power minus 1. So if you simplify all these terms, finally you'll be getting neta is equal to, what is left, m is there, and what is going to cancel, LL gets cancelled here. So L power minus 1. and t power minus 1 goes to numerator, becomes plus 1. So t power minus 1 is left. So this is the dimensional formula for coefficient of viscosity for the most popular important. Okay, my dear students, how to find out the dimensions of this physical quantity? Don't worry by seeing all these half epsilon naught e square. There is a simple method to solve the problem and to find out the dimension formula. What is that simple method? Here actually that is the formula for energy density. Okay, so there is one concept called as energy density. Okay, for which this is the formula half epsilon naught into e square. Okay, so what is this energy density? We shall discuss here now. Okay, so energy density can be taken as energy by volume. Energy is nothing but ml square t power minus 2. Volume is nothing but L cube. So L square L cube gets cancelled. The dimensional formula is nothing but half L power of minus 1 t power of minus 2. This is going to be the dimensional formula here. Hope you have enjoyed this problem. Thank you very much. Have a nice day. Okay, my dear students, how can you solve this problem in a shortcut method? Okay, so he is asking us to find out the dimensional formula of surface tension in terms of energy, velocity and time. Okay, so how are you going to find out that? The general formula for tension is force by length. Okay, I have written force by length. I can take now energy is equal to force into displacement. Here displacement I will take it as length here, because energy and work both are same. So energy I am writing as force by length. Then I can write force is equal to energy by length here. That's it. So instead of tension I will be writing energy by length. Already force by length, one more length is there. So instead of F I am writing E by L. So it is going to become E by L square. And you also know that length is nothing but displacement. You can consider as velocity into time. That's it. Your answer is ready. No need of any raising of powers method. It's very time waste. Okay, then you can just see E is equal to E into, V comes to numerator, becomes V power minus 2 t power minus 2. Your answer is ready in fraction of seconds. You can do this problem without pen and paper also if you practice a lot. Thank you very much. Have a nice day. Okay, my dear students, you can just see this problem here. He is asking us to find out the dimensions of energy in terms of momentum, area and time. So how are you going to find out this one? I'll tell you an amazing short trick where you'll enjoy that method which I'm going to tell. Instead of writing energy is directly proportional to P power A power B, T power C and solving for all these, it's a nonsense and nuisance. Let us have some common sense now. So you can just write here energy is equal to mc square. You all know about this. And you also know that energy is equal to mc into c. Okay. So mc c is nothing but velocity of light. So c you can consider as velocity v. Velocity of light is v. Let us take. So mass into velocity is taken as momentum. So momentum into again velocity. So momentum is taken as p here. But again you have to write velocity in terms of area and time. How are you going to do that one? It's very simple. You can just see here what I am going to do now. I will be writing here area. Area is nothing but L square. That means L is nothing but a power of 1 by 2. Okay. And you know that velocity is nothing but displacement by time. So instead of displacement L here, I will be taking a power 1 by 2. Okay. So I am writing here now a power 1 by 2 by t. So now what I am going to do here is I will just write now p like that only. Instead of velocity I will write a power 1 by 2 divided by t. That's it. I got the answer. Your answer is ready. So the answer is p a power 1 by 2 and t power minus 1. That's it. This is an easy and shortcut method to solve the problem this time. Thank you very much. Have a nice day, baby. Okay, my dear students, I will do these problems which are shown here with an amazing shortcut methods which will save a lot of your time if you are a NEET aspirant. Okay, let us go ahead now. He is asking us to find out the fundamental formula for mass in terms of force, length and time. So you all know that mass is nothing but force by acceleration. Okay, you all know that acceleration can be taken as LT power minus 2. That's it. So your formula is ready. Force length power minus 1 t square. That's it. Your option is ready here. Okay. So now let us go ahead with the second problem. In the second problem, he is asking us to find out the dimensional formula for force in terms of pressure, velocity and time. You know that pressure is equal to force by area. So force is equal to pressure into area. Okay, and he's asking us to find out velocity in terms of area. Area means what you'll write? L square. Area means L square. You know length is nothing but displacement. Displacement is equal to velocity into time. So here instead of displacement d, we can take length here. Length means you can substitute v into t here. So therefore F is equal to pressure. Instead of L we write v square t square. Your formula is ready. Let us go for the third problem. Here he is asking us to find out the dimensional formula for energy in terms of force, acceleration and time. So you all know that energy or work done both are having same formulas, that is force into displacement, which is taken as length here. Okay, so but here acceleration and time is required here. So you all know that here okay, so we can take here energy is equal to force into displacement, and you know acceleration is nothing but LT power minus 2. So L means you can write a t square if you transfer this t here. So therefore energy is nothing but force F. Instead of L you can write a t square. Your formula is ready. Hope you have enjoyed these type of amazing methods to solve the problems. My dear students, I have discovered a simple shortcut method to solve this problem. You can just see here, it's very interesting. If you observe here, see this lengthy method given in the books of previous year questions. So here you can solve this problem with a simple logic. It's very interesting and amazing logic. You can just see here. So he's asking us to find out the dimensions of density in terms of force, length and time. How can you do that one? In a simple shortcut method. It's very simple. You can just write force is equal to mass into acceleration. Okay, and you can write force. Mass is nothing but volume into density, and acceleration you can write it as LT power minus 2. So force, volume means you write L cube, density L t power minus 2. So density if you cube at one place, you can write force. This length is L cube goes to downwards here, L power 4, okay, and t power minus 2. That's it. So density you take at one place, remaining you transferred below force. Below force you can just transfer it. So finally we're getting density is equal to F L power minus 4 t square. See how amazing this trick is. If you like this trick, you can just subscribe to this channel, prescribe to your friends and describe the comments below. Thank you very much. If you want this type of videos, you can just give the comments below. Thank you. My dear students, today I would like to discuss a very amazing short trick where you will enjoy this short trick. You can solve this type of problems in less than 10 seconds. Hope you'll enjoy this session now. You can just see here, he's asking us to find out the surface tension in terms of energy, velocity and time. Generally what you will do and waste you a lot of time by raising the powers. Tension is directly proportional to E power A, V power B and T power C, and you will spend your quality time in an exam in solving this type of problems which waste your time. So I'll tell you an amazing short trick here. So how can you do this one? Now let us see. You can write tension is equal to force by length. Multiply numerator and denominator with length. So length by length. So force into length is force into displacement can be taken as energy. Okay. So you'll write energy now. And in the denominator you'll write length whole square. You know length is nothing but displacement. You can write this as velocity into time whole square. That's it. Your work is done. Over. So tension is having a dimensional formula. E V power minus 2 t power minus 2. Hope you have enjoyed this session. Thank you very much. Have a nice day. If you like this, subscribe to my channel, prescribe to your friends, and describe the comments below what type of shortcuts you need. Thank you. How to find out the dimensions of CV square? It's very simple that it is actually energy formula is half CV square. So instead of taking half does not have dimensions, so CV square is having the dimensional formula for energy, which is ml square t power minus 2. So your answer is ready. Then how to find out the dimensional formula for electric field? You all know F is equal to Q into E. Okay, so this implies that E is equal to F by Q. F is mass into acceleration ml t power minus 2. Q is nothing but current into time. So Q means current into time, because current is nothing but Q by time. So therefore I is taken in symbol called as ampere, and this is time. So ml t power minus 3 a power minus 1, because this t transfers to numerator becomes like this. So this is going to be your dimensional formula for. Friends, how to find out the dimensional formula for Stephen's constant? For that you should understand one concept. You know, intensity of light coming from the sun is directly proportional to fourth power of absolute temperature, and intensity is equal to sigma t power 4. Okay, you should know what is the formula for intensity. Intensity is nothing but power by area. Okay, and you can write sigma t power 4, and power can be written as energy by time. Area is already present here, so sigma t power 4. Then here energy means what? Energy means ml square t power minus 2 divided by time t, and this is area, that is taken as L square, and this is sigma t power 4. T power 4 means T temperature is given by Kelvin K power 4. Therefore L square gets cancelled. Sigma is equal to m. L is not present, L power 0. This T goes to numerator. Okay, so this T goes to numerator becomes T power minus 3, and this Kelvin goes this side becomes K power minus 4. So this is going to be our dimensional formula for Stephen's constant. Find out the dimensional formula for Planck's constant. You all know Planck's constant is find out by the formula energy is equal to h nu. Nu is frequency, which is reciprocal of time. Okay, so nu can be taken as 1 by t also, so I have written h by t here. And now you know h is equal to E into t. You know energy is nothing but m L square t power minus 2, and you can take time as t here. Therefore m L square t power minus 1. This is a dimensional formula for Planck's constant. How to find out the dimensions of latent heat? It is very simple. You all know quantity of heat energy is nothing but mass into latent heat. So latent heat is nothing but energy by mass here. Energy means you all know ml square t power minus 2, and mass is m here. Okay, so therefore gets cancelled. M power 0 L square t power minus 2 is going to be your dimensional formula for latent heat. Okay, my dear students, he is asking us to find out the correct option here. The easiest method to solve this problem is to find the dimensions of these two. Okay, so you know first option, if you observe dimensions of t, whereas dimensions of t1 t2. If you observe dimensions of t is t only, and this is t and t, which is going to be square root of t square. So LHS is equal to RHS. So therefore this is going to be the correct option. Whereas this is here t by t under root going to be 1 here. So this is going to be
t square by t, it is going to be root t. It is not going to be your answer. So here also t square by t square, okay, that is t square by t square. So you're getting here 1, that's it. But this is going to be a correct option. Dear students, how to find out the dimensions of permittivity? You all know the formula. F is equal to 1 by 4 pi epsilon naught q1 q2 by r square. So 4 pi does not have any dimensions. So how are you going to find out the dimensions of this quantity that is called as epsilon naught? So epsilon naught, if you take here, it will become q1 q2 by f will come to denominator fr square. Q1, you know, it is nothing but current into time, so dimensions are 80. So here 80 into 80, because there are two charges, and you know F is nothing but mlt power minus 2, mass into acceleration, okay, mass into acceleration. R is nothing but the distance, that is length here, which can be taken as L square. Okay, so just to see, you can see what is going to happen here. So therefore the dimensions of epsilon naught is m goes to numerator become m power minus 1. This is L cube, which will become L power minus 3. So here t square, this t power minus 2 goes to numerator becomes t power 4. A, here a square. Okay, so in this way you can find out the dimensions of permittivity. Okay, then what are the units of this? How can you find out the units here? You can find out the units by using this physical quantities. Like for example, okay, so charge, both charges are taken as Coulomb square, and Coulomb square divided by Newton. Okay, so force is in the denominator, so we write by Newton. R square means meter square. Okay, so Coulomb square, Newton, meter square. Okay, so third option is going to be your answer. How to find out the dimensional formula for magnetic field? The simple method to find out the dimensions of magnetic field is use this formula. F is equal to BIL. This implies that B is equal to F by IL. F means mass into acceleration, that is mlt power minus 2. I means current, which is represented with ampere A. Length means L here, so LL gets cancelled. The dimensional formula for B is going to be M L power 0, T power minus 2, A power minus 1. That's it. We would find out the dimensions of mass in terms of light velocity of light, universal gravitation constant G, and Planck's constant H. So what is an easy method to find out this one? The easiest method is you can just write F is equal to gmm by r square. Gmm means you can write m1 m2 as m square, so fr square. So therefore you can write m square is equal to fr square by g. Okay, then after that you can just write f into r by g, and f into r is force into displacement, which can be taken as energy into r by g, and you can write energy is equal to h nu. Energy is equal to h nu. Okay, so we can write energy is equal to h nu, or you can write energy is equal to h nu. Nu means frequency, so h by t. So energy can be written as h by t. R by g is already present here. R by g is already present here. Okay, so what can you write this one? So m square, which is taken here, can be written as h into, okay, so what can you write here now? R by t. This is r by t, that means distance by velocity. You can take r by t can be taken as velocity, which can be taken as c here. Okay, so instead of r by t you can write c by g. Okay, so therefore we can write m is equal to h power 1 by 2. If you transfer this to there, it becomes power of 1 by 2, that is square root c power 1 by 2 divided by g power 1 by 2. So which can be written as m is equal to h power 1 by 2 c power 1 by 2 g power of minus 1 by 2. So in this way we can find out the dimensions formula for mass. Hope you have understood. Students, how to find out the dimensional formula for solar constant. See, solar constant and intensity both are having same dimensions, intensity of sunlight. So intensity is nothing but power by area of cross section, power passing per unit area. Power can be taken as energy by time by area. Okay, so therefore intensity is equal to energy. Energy means can take work done, which is force into displacement. Force means mass into acceleration into displacement means L square divided by T, and this is area which can be taken as L square. So therefore we can cancel out this L square and finally write the dimensional formula for intensity as m L power 0 T power minus 2. Next you have to find out the dimensional formula for coefficient of thermal conductivity. Here the concept behind that is, if you take a rod, okay, and heat the rod from below. Here let us take temperature is theta 1, here temperature is theta 2. Length of the rod is L and area of cross section is A. So quantity of heat energy divided by time. Rate of flow of heat is directly proportional to area of cross section. Rate of flow of heat is directly proportional to temperature difference, which can be taken as delta T. And rate of flow of heat okay. So here from this it is understood that rate of flow of heat is directly proportional to A temperature difference delta T divided by length, which is equal to rate of flow of heat energy by time is equal to thermal conductivity. So you can write this as thermal conductivity K A delta T by L. So you have to find out the dimensions of this K now. So here we can write energy. Energy can be taken as ml square T power minus 2 divided by time T. So the dimension is of K, you have to find out. The next is area, which is L square. Delta T can be taken as K Kelvin. Okay, so and length is L. So L square gets cancelled. This L and this L square gets cancelled. So therefore, what is left now? You have to find out the dimensions of this K. So K to one side and remaining you can just send to that side. So here M is present, L is present. This T goes to numerator, become T power minus 3, and this K Kelvin is transferred to that side, becomes K power minus 1. So therefore this is going to be your dimensional formula for thermal conductivity. How can you find out the percentage error? Okay, so to find out the percentage error we have to use PP technique here. What is the meaning of PP technique? PP technique is nothing but power percentage technique. Okay, so what you have to do, multiply these two powers and add with these two powers. Multiply these two, add with these two, multiply with these two, add these two. That's it, your answer is ready. So you can write here now 3 1s are 3 plus 2 2s are 4 plus 1 3s are 3 plus 1 4s are 4. So your answer is ready here. 14% is going to be your answer. Hope you have enjoyed. Can you solve this problem in a shortcut method? He is asking us to find out the dimensional formula for linear momentum in terms of surface tension, moment of inertia and Planck's constant. For that you have to take one shortcut formula. You all know that kinetic energy is equal to P square by 2m. Okay, so 2 does not have any dimensions, So we can write P square is equal to K into M. Okay, so kinetic energy into M. So can we write kinetic energy as work done, which is force into displacement? Okay, so mass is there, you just multiply with r square and divide with r square. Okay, why I am doing, I'll tell you just now. You just see here. So here displacement and radius both are having same dimensions. Now let us see what is going to left. So P square is left here. Force, this radius comes below the force, it becomes force by length, and mr square is going to become moment of inertia. Okay, so therefore P square is going to become force by length, it is going to be surface tension, and I. Okay, so with this it is understood that momentum is directly momentum is square root of SI, so which is S power of 1 by 2 and moment of inertia power of 1 by 2. As h is not present, you can take h as 0. Therefore your option is B. Thank you. Here in this case, how to find out the dimensions of L by RCV, okay, in SI system. Now just see here, L, R, CV are said to be inductance, resistance, capacitance and voltage. Okay, so how are you going to solve this problem? It's very simple here. You all know that inductance by resistance is taken as time constant. That means for this the dimension is T. And now you know that in that CV, if you consider, okay, so Q is equal to CV. Charge is nothing but product of capacitance and voltage, and charge is also having another formula, that is IT. Okay, why it is charge is equal to I into T, current into time? Because current is equal to charge by time. Okay, so therefore charge is equal to current into time. Therefore the dimensions of Q can be taken as, current is written with A symbol, ampere, and time with T. So Q we got it as AT. So therefore our formula given in this problem is L by RCV, for which L by R is considered to be T and CV is considered to be AT. That's it. TT gets cancelled. Your dimensional formula is A power minus 1. That's it. Thank you. How will you solve this previous year NEET question in a simple shortcut method? There is one technique called as power percentage technique. The simple thing is, I have written powers here and percentages here. You just multiply all these powers and add them, so your answer will be ready. For example, 2 into 1 is 2, and half into 2 is nothing but 1. 1 by 3 into 3 is nothing but again 1, and 3 into 4 is nothing but 12. So what you need to do is, you have to take 2, 1, 1 and 12 and add them. That's it. Your answer is ready. You have to add all this. So therefore power percentage technique means power and percentage should be multiplied and they should be added. That's it. Your answer is 2 plus 1 plus 1 plus 12. So therefore your answer is going to be 16. That is called the percentage. That's it. My dear students, how to find out the dimensions of pressure here, okay, in terms of intensity as well as speed of light. You all know that intensity is equal to power passing per unit area. Okay, power passing per unit area. So you know power is nothing but energy by time. So already area is there in the denominator. I will write power as energy by time. Okay, and you also know energy is nothing but force into displacement by area into time. Okay, so you can just club these two. You can write force by area separately and displacement by time here. So intensity is taken as force by area is nothing but pressure, displacement by time is nothing but velocity. You can take instead of v, velocity of light. Okay, this implies that pressure is nothing but intensity by velocity of light. Okay, so this is going to be your correct answer. Thank you very much. How to find out the shortcut method to find out the dimensions of angular velocity? Okay, so there are four options given, but how can you find out in an easy way? So the shortcut method here is, you can write, we all know that V is equal to R omega. Omega is equal to V by R, you can consider capital R. Okay, you all know that V is equal to escape velocity. If you consider, it is going to be 2 gm by r. This is the formula for escape velocity. So what you are going to do is, here you will write escape velocity formula, that is 2 gm by r and divided by r. Okay, so if you take this r to inside, it will become r square. So totally it is going to become 2 gm by r into r square, because this you are considering inside the root. So therefore your final answer is going to be 2 gm by r cube. Okay, so your correct option is fourth option. You can just see, you have to find out the dimensions of energy stored. Okay, the dimensions of energy stored in terms of stress and Young's modulus here. So how can you do that one? You all know that energy stored per unit volume, he is asking us for this. So energy, so what is an energy actually? If for example, if you apply certain load on a wire of length L, this wire gets extended because of increase in the length. Okay, so energy means work done. Work done can be taken as force into displacement. Increase in the length is going to be the displacement, and volume is nothing but area into length. So here you can separate these two. What can you do? You can separate these two. Okay, then you will be getting force by area is nothing but stress, and delta L by L is taken as strain. And you also know that Y is nothing but stress by strain. This implies that strain is considered as stress by Y, Young's modulus, that can be taken as S by Y according to this formula. So what are you going to do now? This if you substitute here, then you will be getting energy. Okay, so energy by volume can be considered as, here stress means S, you can write stress as S according to the problem, and strain means you can write this one S by Y into S by Y. So your answer is going to be S square by Y. So in this way you can get a shortcut formula for energy by volume. So therefore your correct option is A option.